Welcome to this video all about numerical proportion and recipes. The questions, clues and solutions can all be found in handy PDF booklets at mathsupgrade.co.uk. This video is all about non-calculated questions. Question 1 tells us that 8 identical pens cost £12. We need to work out the cost of 10 of those pens. So I'm just going to write that as an equality. So 8 pens is equivalent to £12. Now I need to get to 10 pens, so I need to find a stage which has got a common factor of 10 and 8. So a common factor of 10 and 8 is 2. I can easily get to 2 pens by dividing 8 pens by 4. So I need to divide this side, the amount, by 4 as well. So divide £12 by 4, I'll get £3. Now to get from 2 pens to 10 pens, I need to multiply by 5. So if I multiply this side by 5 as well, 3 times 5 is £15. So the answer is £15 for 2 marks. For question 2, I'm told that 3 kilograms of meat costs £54. Nina needs to buy 2 kilograms of meat. Need to work out how much she pays. So I'm going to write an equivalency. 3 kilograms is equivalent to £54. I need to get to 2 kilograms. So I'm going to do that in 2 steps. I'm going to find a common factor of 2 and 3, which is just 1. So to get from 3 kilograms to 1 kilogram, I'm going to divide by 3 on this side. So I'm going to divide £54 by 3. That gives me £18. Now, to get from 1 kilograms to 2 kilograms, I'm going to multiply by 2 on this side. So multiplying the price by 2, I'll get £36 for 2 marks. In question 3, we're given some instructions for making a drink, and we're asked to find how much drink someone's made, given the fact that they use 5 litres of water. So in this question, we're just going to remind ourselves that 1000 millilitres is equal to 1 litre. And we're going to set up the question with the information given like this. So 100 millilitres is equivalent to 2 litres of water. That's what you'd mix it with. So if I need to get to 5 litres of water, I need to find the highest common factor of 2 and 5. And the common factor is 1. So I'm going to go from 2 litres to 1 litre by dividing by 2 on this side. So I need to divide by 2 on this side. That'll give me 50 millilitres. Then to get from 1 litre to 5 litres, I'm going to multiply by 5 on this side, and I'm going to multiply by 5 on this side. That'll give me 250 millilitres. Now the last thing I need to do is need to work out how much total drink he's made. He hasn't just made 5 litres, he's also mixed it with this much juice, 250 ml. So he's made 5 litres plus 250 millilitres, and 250 millilitres is 0.25 litres by dividing by 1000. So adding those together, I'd get 5.25 litres for 3 marks. In question 4, we're given the ingredients needed for 16 flapjacks. We need to work out how much of each of the ingredients we need for 24 flapjacks. So I'm going to set this up as a proportion question again. I'm going to list the ingredients for 16 flapjacks here, and I need to get to 24 flapjacks. So I need to find a common factor of 16 and 24. The highest common factor is 8. So to go from 16 to 8, I need to divide everything by 2, which I've got here. 120 divided by 2 is 60, 140 divided by 2 is 70, 250 divided by 2 is 125, and 2 spoons becomes 1 spoon. Then I need to multiply by 3, since 8 times 3 is 24. So multiplying everything by 3, I'll get these ingredients here, and listing them there would get me 3. In question 5, we're told that Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, and 2 times as much butter as sugar. We're told she's going to make 60 biscuits. We need to work out how much flour she needs. So I'm just going to underline this key information here, and I'm just going to write how much flour she would need. If she needs 50 grams of sugar, 3 times 50 would give me 150 grams of flour, and 2 times 50 would give me 100 grams of butter. So here I've written 15 biscuits and the ingredients that she needs. I need to get to 60 biscuits. Since 60 divided by 15 is 4, I need to multiply everything here by 4. So flour would be 150 times 4, which gives me 600 grams, and that's 3 marks. In part B, we're told that Dion has to buy all the butter she needs to make 60 biscuits, and she can only buy the butter in packs of 250 grams. So we need to work out how many packs of butter she needs to buy. Remember, we worked out 400 grams of butter is what she requires. So if I do 400 divided by the size of each pack, 250, that'll tell me how many packs she needs as a decimal. So 400 divided by 250, without a calculator, I can write that as a fraction. And then I'm just going to simplify the fraction by dividing the top and bottom by a common factor, which is 10. Then I can divide by another common factor, which is 5. That's the same as 8/5. 8 divided by 5 is the same as 16 divided by 10. 16 divided by 10 is 1.6. So, since you cannot buy 1.6 packs, she'll need to buy 2 packs. 1 pack won't be enough, 2 packs she'll have some left over, but that's how many packs she needs, and that's 5 marks for that whole question. In question 6, we're given the instructions to make a fizzy drink. Shahid thinks he's got 300 ml of orange juice and 200 ml of lemonade. If he's correct, what's the greatest amount of fizzy drink he can make? So in this question, I'm just going to work out the ratio of orange juice to 1 part of lemonade. I can get that by dividing 5 by 2. That means I need 2 parts of orange juice for every 1 part of lemonade. If I do the same for Shahid, if I do 300 divided by 200, Shahid's only got 1.5 parts of orange juice per 1 part of lemonade. So he's definitely going to use all of his orange juice. So assuming he uses all of his orange juice, and we know that the equivalency is 5 parts for every 2 parts. If he's going to use all of his orange juice, that's 300 ml. So I need to go from 5 parts to 300 ml. So each part must be worth 60 ml. If I then times his lemonade, this 2 parts, by 60, that means he'll need 120 ml of lemonade. So he'll use all his orange juice here, 300 ml, and he'll use 120 ml of lemonade. In total, he will have made 420 ml of that fizzy drink, and that's 3 marks. In part B, we're told that Shahid does have 300 ml of orange juice, but he only has 160 ml of lemonade. So we're asked whether that affects the greatest amount of drink he can make, and we've got to give a reason for our answer for 1 mark. So if you remember, in part A, we worked out that he needed 120 ml of lemonade. So the fact he's only got 160 ml of lemonade won't affect the answer in part A, since only 120 ml was needed. If you put all the reasoning there, you'll get that 1 mark. So that's 4 marks altogether for that question. In question 7, we're told it will take 120 minutes to fill a swimming pool using water from 5 different taps. We're asked how many minutes it will take to fill the pool if only 3 of the taps are used. So in this question, I'm just going to work out the total filling time if 1 tap was used by working out the minutes per tap, which is 120, and multiplying by the number of taps, which is 5. That will give me 600 minutes if 1 tap was used. Now, since we're using 3 taps, I can do 600 divided by 3, which gives me 200 minutes, and that's 2 marks. The next part of the question asks us to state an assumption we made in working out the answer to part A. Well, here, it doesn't say anywhere that the taps have got the same flow rate, but we have to assume that. So I've just put here that we assumed that all the taps have the same flow rate, and that would be 3 marks for the whole question. In question 8, we're told that it takes 12 men 5 days to complete a job. We need to work out how many days it would take 3 men to complete the same job. So like question 7, this question is not as straightforward as some of the other proportion questions. What we can do is we can work out the total time taken for 1 man to do the job by multiplying the number of men by the number of days. That would give us 60 days. So it takes 60 days for 1 man to complete that job. I can then just divide that by the number of men I've got, which is 3, and that will give me 20 days to complete that job. In part B, we first of all asked an assumption that we made in working out their answer. And so I've just said that all the men will be working at the same rate. If our assumption is not correct, then the answer to part A can either be greater or less depending on the men's work rate. The whole question there was worth 4 marks. In question 9, we're told that a factory makes 450 pies every day. The pies are chicken pies or steak pies, and each day Milo takes a sample of 15 pies to check. This next sentence is critical to the question. The proportion of the pies in his sample that are chicken is the same as the proportion of pies made that day that are chicken. On Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. We need to work out the total number of chicken pies that were made on Monday. So if I underline the key information, and if I write this sentence here as an equation, as a formula. So I've written the number of chicken in the sample divided by the total sample size. That's the proportion of pies in the sample that are chicken. So this part of the sentence here is this side of this formula. And that's the same as, so it's equal to the proportion of pies made that day that are chicken. So the proportion of pies that are made that day. So the total number of chicken divided by the total number of pies. So we're told it calculates that you need exactly 4 chicken pies in the sample. So the number of chicken pies in the sample is 4, so that's the top of that fraction there. And the total sample size is 15, that's you told it at the top of the question here. So 4 over 15 is equal to the total number of chicken pies that are made, which is what we need to work out, the numerator here, divided by the total number of pies made in a day. And that's 450 pies made every day. So now I just need to work out the numerator of this fraction here. I need to rearrange this. So think about solving equations. To get an unknown by itself, I need to get rid of everything else on this side. At the moment, this unknown here is being divided by 450. So the inverse of divide by 450 is multiply by 450. I need to do that to both sides. So I multiply by 450 on both sides. I end up with 450 times 4 over 15 equals, and then this unknown. I can then work this out. So 450 times 4, that's the same as 450 times 2 and times 2 again, which is 1800. And then divide by 15, you work this out using short division, that gives you 120 pies. That's 2 marks. Part B is worth another 2 marks. We're told that on Tuesday the number of steak pies he needs in his sample is 6, correct to the nearest whole number. He takes at random a pie from the 450 pies made on Tuesday. We need to work out the lower bound of the probability that the pie is a steak pie. So this question involves bounds. If you're not sure about bounds, be sure to check out a video on that topic, which is on this channel. If you remember, if you think back to part A, I had the number of chicken pies in the sample divided by the total sample size is equal to the total number of chicken divided by the total number of pies. That comes from this statement here. Well, that's also going to be true, right, for part B. So what we're going to do, we're going to replace chicken here with steak. So the number of steak in the sample divided by the total sample size is equal to the total number of steak divided by the total number of pies. Now, we're told that the number of steak in the sample is 6 to the nearest whole number. So the lowest it could be is 5.5. Since when I round 5.5 to the nearest whole number, I'll get 6. If it was 5.4, that would round to 5. So 5.5 is the lowest number that I can get, that when I've rounded it to the nearest whole number, I get 6. So this is 5.5. The total sample size is still 15. And I need to work out this probability here, which is the total number of steak divided by the total number of pies. That's the probability of picking a steak pie. So 5.5 over 15, I need to work that out. I can leave it as a fraction or a decimal or a percentage since it's probability. I'm going to leave it as a fraction, but I'm just going to write it as a proper fraction, which is with whole numbers on the numerator and denominator. I'm going to double the top, double the bottom. That's 11 over 30, and that's in its simplest form. The whole question there is worth 4 marks. In question 10, we're told that a company orders a number of bottles from a factory. The 8 machines in the factory could make all the bottles in 5 days. All the machines work at the same rate. For 2 days, only 4 machines are used to make the bottles. From the 3rd day, all 8 machines are used to make the bottles. We need to work out the total number of days taken to make all the bottles. So with this question, which is worth 3 marks, the trick is to work out the total manufacturing time first. The total manufacturing time is essentially the number of machines times the number of days. That sort of gives us the number of machine days. So 8 times 5 from these numbers here gives us 40 days. That means it would either take one machine 40 days to make all the bottles, or it would take 40 machines 1 day to make all the bottles. Right, so this is our target. So in the first 2 days, only 4 machines were used to make bottles. So 2 machines times 4 days means we had 8 machine days. So that's 8 machine days there in the first 2 days. We've still got 32 machine days left. So if on the remaining days all 8 machines are used, we've got 32 machine days left. Divide that by 8. That means 4 days of all the machines running will mean that the bottles are all completed. So the 2 days for these machines plus the 4 days with all the machines gives us 6 days in total. That question there was worth 3 marks. If you struggled with it, be sure to look through this video again and check everything that you've done and try and get all the marks in every single question. Thanks for watching.